We live in a world surrounded by data, and understanding that data is crucial for business decisions. Take search engines as an example. They help us navigate vast amounts of data in a matter of seconds. But imagine our internet without any search engines. Millions of websites are created each month, but we would have no way to uncover relevant information without search engines. That's the problem that businesses face for their own data. Over the course of weeks and months, businesses accumulate a virtually endless stream of data. Traditionally, teams of data analysts use spreadsheets to sort the data, to try to spot patterns and apply complex formulas, a process that takes weeks or even months. That's where Quantum Leap Analyst comes in. It's simple enough for anyone to use on their laptop or desktop, like a search engine. You no longer have to be a math whiz to understand your data. With just a few clicks, you can immediately see key patterns and interact with the data. Let the data talk to you and find the answers you need. This tutorial is going to show you how to use different features of the software with a real-world example of data from a hospital to see how patient activities affect cost for the hospital. Once the program is opened, you can import data by clicking on File, then Import. In the Import screen, there are many options to load data, and the program can work with diverse data environments using any data source. The first option is to load data from a file. This is the option we will use for the tutorial. Other options include loading data from a relational database, plain text, or a downloaded file. The data set you see in this demo is hospital discharge data. The data contains records for more than 1 million patients. Each record contains 177 attributes. On the left panel, you can see a list of all 177 attributes, such as gender, ethnicity, and length of stay. We can click on any attribute, let's say principal diagnosis. The right side then shows all the states from the attribute, which are different diagnoses the patients received. They are ranked by how many patients received each diagnosis. This is one way you can visually see the distribution of any attribute. As you can see, the single most prevalent diagnosis was a single birth in the hospital without a cesarean, occurring at 7% for 73,131 patients. Usually, in a data set this large, discovering key information can be very challenging. But, as you can see, with just a single click, we were able to discover what the most common diagnosis was in the hospital. We just sorted through more than 1 million patient records, each of which has more than 100 attributes, with many attributes having more than 1,000 states. This is the kind of automatic search we will be performing to identify patterns. One important insight we can gain from this data set is, how much did patients pay for their hospital visits? To find out, let's look at the total charges attribute. Clicking on it, we see on the right that the software has automatically categorized how much different patients paid into 5 buckets. Each represent the dollar amount paid by 20% of the patients. For example, in the first bucket, patients paid less than $5,842.50. The exact number of patients paying this dollar range is 207,668. As you can see, the 20% of the patient paying the highest amount is $62,173.50 or more. If you don't like the generated buckets, you can design your own. To create custom buckets, click on the far right icon, highlight the category button, and select Custom. You can then increase or decrease the number of states or buckets, and also adjust the values based on what you're interested in finding out. There might be times when you want to reduce the number of states for an attribute. Doing so provides a less detailed analysis, but allows more generalizations to be made to see the bigger picture. It's useful for analyzing attributes that contain many states in order to reduce the complexity of your data. Let's try it with the disposition attribute, which contains information for where patients are discharged after they leave the hospital. As you can see on the right, there are 14 states within disposition, or 14 different places where patients are discharged. They are ranked by frequency, with the most patients discharged to their homes. Other options include different kinds of acute care and non-acute care. Let's say we want to simplify this data into two categories, acute and non-acute care. There are two kinds of acute care, and we will consider all other options as non-acute care. To generalize these attributes, right-click on Disposition and click on Manage States. Then highlight the two types of acute care, which we want to generalize as the same type, and right-click and choose Set Synonym. We'll call this acute care. As you can see, the two types of acute care have been aggregated or generalized as the one state that we named acute care. Now we will highlight the remaining states to generalize them as non-acute care. Right-click and choose Set Synonym, and we will call these attributes non-acute care. Now we see that the original 14 states have been generalized into two, acute and non-acute. Click OK, and we're back at the data screen. You can see that the states are now updated as acute and non-acute, along with the corresponding statistics. If you want to undo the generalization and reveal the original states, just right-click on Disposition, click on Manage States, then right-click on the acute care generalization we created, and choose Remove Synonym. We can do the same with non-acute care, and as you see, we have deleted the generalizations and reverted to the original states. In the main data screen, under Attributes, you can see that some have a red icon next to it. The red icon indicates that the attribute is ignored by the user in the analysis. This feature can be useful to ignore non-essential attributes such as descriptive or annotative data. Just click on the attribute to highlight it, then click the red Ignore icon on the bottom. To include the attribute back into the analysis, just click the green check mark at the bottom. One way to hone in on particular aspects of the data is by filtering it. The filtering option allows you to see a smaller subcategory of data. Let's say we want to see the data for patients whose diagnosis was pregnancy. We can find this data from the larger category of major diagnostics. Highlight it in the attributes list, and to the right you can see the different diagnostics patients received in order of prevalence. Now we'll zoom in on patients whose diagnosis was pregnancy. Go to the Filter drop-down at the top and select New to add a filter. From the list of categories, select Major Diagnostic, and then select Pregnancy. Then click OK. You'll then see an option for Matched. Click on it. The software will now display only the records in the pregnancy and childbirth diagnostic category, which is about 13% of the data. As you can see, there are about 135,000 records matching the filter we created. Next to the option for matched, there is also an option for unmatched, where you can see records that do not meet the filter's criteria. This allows you to focus your analysis on a subpopulation of your data. In the hospital data we're using, there are 177 attributes containing information about the patients. Some of these attributes may be related, and it only takes one click to find out. Locate the checkerboard icon at the top to view correlations. A map then appears visually highlighting correlations. We currently show correlations between continuous attributes, and will extend this to all attributes in an upcoming version. In the future versions, we will show correlations for categorical data. As you can see, only 3 boxes are shaded, meaning there are 3 correlations. The stronger the correlation, the darker the shading. Let's move over to the darkest blue, the strongest correlation. Not surprisingly, it is the relation between total charges and length of stay. Now move to the left, the box with a lighter shade, which we discover is the relation between total charges and patient age. Let's find out the third and weakest correlation, the box with the lightest shade of blue. It is the relation between the length of stay and the patient's age. To see these correlations numerically, click on the icon on the top right, which opens a list of all the pairs that correlate in the data, their correlation, and the absolute value of their correlation. You can sort the list in ascending or descending order by clicking at the top of each column. At the top of the list, we see a list of attributes compared against themselves, resulting in perfect correlation of 1. Scrolling down, you can see 3 variables with different correlations. For example, we find that total charges compared against the length of stay has a correlation of 0.461. We see that the rest of the correlations on the list are blank, since they are categories and do not contain continuous data. This is one example where you can use the software to quickly find correlations, which could take significantly longer with traditional spreadsheet calculations. And if your data had many more correlations, you would see many more boxes shaded at different intensities, providing you a visual impression as well as numerical references of the key relations in your data. Data analysis leads us to discoveries, shedding light on patterns and trends of certain demographics or figures. This software allows you to make these important discoveries with just one click. The software can objectively display influential patterns and trends hidden in a dataset. To start, click on the Discovery tab on the lower left, which opens the Discovery screen. Then we will tell the software where to look for patterns, which is the list of target attributes. Let's choose Total Charges and click the Search button. The software will now automatically and objectively look for any patterns surrounding total charges. Similar to doing a web search, we don't need to tell the software what conditions to look for or specify constraints. We're just telling the software to find notable patterns surrounding total charges. As the results appear, let's open the display legend at the top. Click on Display. The legend allows us to filter, sort, and rank the results, similar to what you can do with search engine results. There are 2 ways to sort the results, by strength and by target state coverage. We'll first examine the results sorted by target state coverage. This means that we rank the results based on the number of records in the target state that the pattern covers. The software has created 5 different charge buckets, each with a different color. As you can see, red is the lowest charge bucket, while orange is the highest charge bucket, covering almost half of all the states. Let's look at the results. The first pattern is the most prevalent one. It is an orange pattern, and at 48.5%, explains the pattern for almost half of the hospital bills with high charges. On the right are 3 attributes that describe the pattern. This means that almost half of the most expensive hospital bills is for staying 4.5 days or more for acute care, with patients having traditional insurance coverage. As you can see, the description on the right provides informative insight for the result. On the left, we see that the average charge for patients in this pattern was $134,190.14. This pattern explains about 15% of the data, which is about 175,000 patients out of more than 1 million in this data. In the results, we can also see the strength of the pattern. The strength is the percentage of patients who portray this pattern. And the most prevalent pattern has a strength of 64.1%. On the chart, we can see the orange bucket as the most prevalent, while the remaining patients are distributed in the rest of the cost buckets. For more insight, let's look at the pattern distribution chart. Click on Group by Collection at the top and a blue chart appears. Click on it to open, and the chart shows the amount of target states and the strength of each pattern. As you can see, the top 2 patterns are wide, meaning they cover the most targets as the most prevalent patterns. You can see the numeric percentages on the right, 48.5% for the first pattern and 42.2% for the second pattern. You can also interact with the results. Let's click on the red bucket. The results have now changed to using the red bucket as the reference. In the pattern distribution chart, the wide pattern explains much of the low costs, which is the pattern that we saw earlier. The remaining patterns are much narrower in terms of coverage. The patterns also vary in complexity. On the right, you can see that the second pattern now includes 4 factors, as is the next one. They both have correspondingly low coverage. Now, let's click on the orange bucket to examine the high charges. The results have now changed to using the orange bucket as the reference. In the pattern distribution chart, there is again one dominant pattern, and you can see the fall off in terms of the coverage. We will now explore how the results change when we change the sorting criteria from target state coverage to strength. As you can see, the pattern distribution chart changes significantly. Looking at the first 2 patterns, we see that they are extremely strong. They are pure patterns, and to the right involves the name of the facility. You can also notice that the data coverage is much narrower. The overall change is that by viewing patterns in the context of strength, you can isolate strong but tighter clusters of data. In comparison, when sorting by target state coverage, you can get a broader view of the data patterns, but you won't get a view of the data in terms of maximum strength. Let's explore more filtering options. Currently, you can see data coverage of 1% is highlighted. This means that all the patterns in the results list are those covering at least 1% of the data. Let's try another option, data coverage of 50 records. As you can see, the list of patterns is increased significantly as patterns that have a lower threshold of data coverage are being included. The different filtering and sorting options you have seen here demonstrate the software's flexibility and level of details for viewing and ranking the resulting patterns. You can control the metrics used to rank the patterns, including target states coverage and strength, as well as the data support threshold at any values, such as 1% or 50 records. This software allows you to explore data subsets within your data environment with only a few clicks. You can also gain more insight into the data by ranking the individual attributes of the data based on their importance against their target. Just click on the attributes icon on the top right. You will then see a ranked list of attributes based on both their individual importance against the target and their importance in the context of patterns. Take a look at the rank, and you can see that the length of stay is the most informative and important attribute in relation to the target of total charges. It makes sense that the longer a patient stays at the hospital, the higher the total charges. Now, look over to the pattern score, and we see that the length of stay is also present prominently in many of the patterns involving interactions with other attributes. This gives us the insight that length of stay is not only important by itself, but also participates in many important and informative patterns. Looking further down the list, to admission source license. It's not important by itself, as you can see, but surprisingly, when combined with other factors, it becomes extremely important. By seeing both the importance of attributes by themselves and their importance in the context of a pattern, you can get a better understanding with what's happening in your data and the factors contributing to the information relevant to the target. To compare patterns, you can aggregate them into a sortable list. Click on the icon on the top left of each pattern summary, and you will see a list of patterns that have been aggregated together in one list. We have the same option of the data coverage filter, which is currently selected at 1%. We can now sort the patterns in this list based on several criteria. Let's say we want to sort by the strength against the orange bucket. Click on the orange thermometer, and you can see that the top pattern in this list has caught 71% of the data in the orange bucket. Similarly, click on the red thermometer, and we get a different ranking. The top pattern is 100% strength in red, and notice that the pattern description has changed. Go back to the orange bucket and highlight the pattern. Then right-click, and you have many options. Copy the pattern, view the underlying data, or perform a range of other advanced analytic functions for the underlying data of this particular pattern. In this important feature of the software, you can right-click on any pattern you're interested in and have access to these options, providing you a range of pattern-centric analytic capability. Another advanced feature within Pattern List is the comparative analysis between the statistics of the pattern and the statistics across the data as a whole. To start, highlight the pattern, then click the bar graph icon on the upper left, and a pair of histograms appears. The bottom one shows the distribution of target states across all data. The 5 cost buckets are equally divided into 20 percentile quintiles. As a comparison, the histogram at the top shows significant enhancement of the orange bucket, where the 3-dimensional pattern is satisfied. Sharing your findings from the software is easy. Let's look at saving data from a pattern. In the Discovery screen, click on the down arrow to the right of a pattern, and you have the option to save the data associated with the pattern, the underlying data describing the pattern, or the pattern itself. The data is saved into the files you can export and reuse later. To save a visual summary for a pattern, click Create Report. Name the report. In this case, we'll call it Test. Now we can go back and add patterns to test. To view the report, click the report icon on the top right, which lists the patterns we just added in a formatted summary. This is one way to save your findings from the software. Another way to save patterns is to simply capture the screen. On the PC, you can use the standard Alt-Print option to copy the screen onto the clipboard and then paste into a word processing or image processing software. On the Mac, you can use the system application Grab to capture the screen and save the image. The patterns list you see in the software is only the starting point for data analysis. Let's dig deeper by comparing data within a pattern. The data comparison feature in the software allows you to identify and rank other attributes in the data beyond the attributes describing the pattern, which might help to differentiate the target. Click on the data comparison icon on the right. Let's rank the results. The rank is based on the ability of attributes to differentiate against the target, in this case, charges. Let's go back to the display legend and notice that the target attribute, the 5 buckets, can be further organized into 2 groups, Group A and Group B. By default, only the highest charge is in Group A, while all others are in Group B. We can mix and match the groups and change the order, and even ignore certain states by clicking on the X. Let's say we just want to focus on the high versus low. We can simply remove the ones in the middle. With a few clicks, you have the flexibility to organize and rearrange the target. Below the groups is a ranked list of all other attributes in the data, based on their ability to further differentiate into Group A and Group B. Let's try clicking on Principal Procedure, the third one on the list. On the right appear 2 histograms representing Group A and Group B. As you can see, continuous invasive mechanical ventilation for more than 96 hours is prevalent at a 5% frequency in Group A, but only at a 0.3% frequency in Group B. Beyond the 3 factors defining the envelope pattern, we can dig deeper with just a few clicks and identify the key principal procedure. Let's try another analysis. Observing the impact of principal procedure on cost. Right-click on the selected procedure and click Add Filter. You can see the principal procedure being appended to the filter that's already defined by the pattern. Let's show the statistics pane and look at the impact of adding the principal procedure for treatment to the pattern. With this procedure included, you can see that the average cost per charge is now $302,000. In contrast, the current pattern has an average cost of $134,000. Adding continuous invasive mechanical ventilation for more than 96 hours has more than doubled the charges. As you can see, the data comparison feature allows you to explore more attributes in the data than the ones involved in the initial pattern. Another way to visually explore patterns is heat maps. They create a more targeted data model of all data triggered around a pattern of interest. Click on the heat map icon to the right of the pattern. A color-coded map then appears. You can reorganize the map by simply dragging and dropping, like moving type of care down to become part of the rows. As you can see, coverage type is now the inner set of columns, and length of stay the outer set of columns. Let's look at the legend by clicking on Display. Similar to the Discovery screen, you can view all the data in the context of different metrics. Here, we're looking at the target state coverage associated with each combination of coverage type, including the length of stay, type of care, and the associated statistics. You can right-click within the heat map and view a wide range of statistics associated with the target. Let's choose Average. You can then see that every cell represents a combination or a particular pattern. The intensity of the shaded blue represents the charges, with higher charges being darker. We've got a pattern with managed care. The length of stay is 5 days or more, the type of care being acute, and it has data coverage of 22,312, with average cost being $170,662.68. To analyze further, let's highlight the cell and make an impact analysis. We have the variables coverage type, length of stay, and type of care. Are all three variables equally important in explaining this charge? To find out, let's unclick length of stay to take it out of the pattern. You can see that our highlighted cell has now gone down to about 57,000. Let's include length of stay back in, and now you can see that the cell remains highlighted, with the cost going up to about 170,000. From this observation, we can conclude that length of stay has a significant impact on cost. Let's look at the impact of type of care. Unclick it to remove it from the pattern, and you can see that the cost drops from about 170,000 to close to 150,000. We can conclude that type of care does not have a significant impact on cost. Let's examine coverage type. Click on type of care to include it back in and unclick coverage type. The total charges have gone down to about 126,000. We conclude that while coverage type has a slightly greater impact on cost than type of care, it does not have as significant of an impact on cost as the length of stay. Within the heat map, you can also add more variables and examine their impact. You can create targeted data models and have an extended pivot table displayed in the context of the map. By clicking and unclicking variables, we've performed what traditionally would have been sophisticated impact analysis on a pattern to find the relative importance of each variable in contributing to the strength of the overall pattern. The software allows for multidimensional analysis of data not only within a pattern, but also across different patterns. To start, click on the decision tree icon on the right. The decision tree, also called the pattern tree, maps the relationships between all the patterns previously listed. Let's mouse over the type of care as being acute. The pie chart is mostly orange, indicating that if the length of stay is more than 5 days, the type of care is acute. As you can see, if we extend the pattern beyond this point, a significant fraction of them are orange. Let's look at the type of care as being chemical dependency. You can see that the predominant bucket is red at 55%, even though the length of stay is 5 days or more. With the decision tree, you can explore the relationships between patterns to identify critical branching points where behavior of a pattern changes according to the target state. This analysis is useful for guiding practical decisions to make targeted changes to affect an outcome. The statistical data comprising a pattern can be viewed in detail or saved for further analysis. Just click on the left icon associated with each pattern. You'll then see the underlying data subset matching the pattern. On the left, highlighted in yellow, is the target attribute, in this case the total charges. Each column is sortable. Just click on the name of the column. As you can see, it has been sorted in ascending order. Clicking on it again, and it's now in descending order. The 3 columns highlighted in blue, length of stay, type of care, and coverage type, represent the attributes that form the pattern. The remaining attributes to the right consist of all other attributes in the dataset. The data you see on the screen can be viewed and analyzed using a variety of statistical methods. They can also be saved by clicking on the download icon at the top. The output file can then be imported to any other analysis packages or further analyzed within Analyst itself. You also have the option to save the pattern, which can then be applied subsequently as filters on the new data. In the data view, you can also perform simple visual analytics. Let's select one of the attributes in the data, age range, then click on the histogram icon at the top right. You'll then see a visualization of the distribution of age range for the pattern. You can see that in the age range, the distribution is skewed towards the high age range, meaning that older patients tend to have a high hospital bill. This visual analysis is another way to dig deeper into the pattern's underlying data and to be able to hone in on certain attributes. Another dimension for data discovery is to use scatter plots to view the pattern data in the context of the global data environment. To start, click on the scatter plot icon to the right. The scatter plot then opens to visually display the area of interest, or the data subset, the pattern encompasses in the context of the global data. The X and Y axes are length of stay and type of care. You can substitute other attributes that form a pattern for the X and Y axes to examine various two-way relationships and to see how they fit within the global context. You can also use the jitter slider bar to the right to adjust the resolution of the data. Adding more vantage points to examining data is the Advanced Search tools. On the Discovery screen, you can view advanced search options by clicking the plus sign next to Advanced. You can control the number of models built in the underlying data. In this example, there are 20 collections of models. You can expand each collection to show the familiar pattern list. You can expand all 20 for a closer look. Each of the 20 collections is a result of the Discovery engine examining the data in slightly different ways. It's like having 20 cameras on a data train to capture different angles. Another option in advanced search is to force the patterns to include one or more attributes of your choice. You can expand the selection to pick any of the attributes as a way to guide the search. This is a useful feature to test an idea or hypothesis for attributes in the patterns. Let's try it with the major diagnostic category. As you can see, all the patterns now contain the major diagnostic category as one of the attributes. A corresponding feature is to exclude one or more attributes from participating in the patterns. You can also select them from the corresponding drop-down menu. This is useful if you need to find weaker or more subtle patterns that might be overshadowed by dominant attributes affecting a pattern. Let's try excluding length of stay, which we know dominantly affects total cost. As you can see, none of the patterns contain length of stay as an attribute. In this software, you can have creative freedom to explore your own patterns. You can explore certain sets of attributes in more detail and view the resulting pattern by using the Custom Collections feature. Just click on the plus icon on the top right and select the desired attributes. Let's try a few: disposition, length of stay, and major diagnostic category. There's got to be patterns from these attributes. Click Search and you get a custom collection of patterns. Let's expand the collection and we see the list of patterns involving these 3 attributes. This is a useful feature to hone in on attributes and dig really deep on patterns that matter. In this tutorial, you've seen some of the crucial ways Quantum Leap Analyst can explore and discover patterns. You've seen how a few mouse clicks can bring about interesting discoveries and practical insight that can influence businesses and industries. With the software's intuitive interface and visual approach, the learning curve to software data analysis is lowered, minimizing the barrier to entry for any individual or organization looking to reap the rewards of good, comprehensive data analysis. With this tutorial, you can use the software's innovative tools to discover patterns in an interactive manner. Unlike one-directional, traditional business intelligence products, you can let the data talk to you as well as talk to your data. You can let the software scan for patterns objectively and then set your own parameters to hone in on specific areas to test your hypothesis and discover novel relationships. The software can run without any guidance or run with varying degrees of guidance from you. You can start with a full conception of what you're looking for, or start with no conceptions and develop ideas with the software. This tutorial only scratches the surface to give you an idea of the software's unique and innovative capabilities. The potential to make the biggest impact with your data is now up to you.